Okay, we're going to continue on with our chi-square test, and we're going to do the general form of the one-way chi-square, which is nice because we went from probability with jelly beans to black and white, a nice extension from the probability work that we did to get to our first inferential test, which is the chi-square test. I'm going to now extend that and generalize that chi-square test to what's referred to as a one-way chi-square. And I'm going to do that with a different study. I'm going to look at eye color. So I have a sample of 30 people, and I look at their eye color, and I write down whatever their eye color is. And I have 3 eye colors in my sample. 10 people were brown, 5 had blue eyes, 15 had green eyes. My null hypothesis is that the breakdown by eye color, there's no differences in terms of the proportion of people by eye color, right? In the population, there's an equal number of brown, blue, and green-eyed people. If my sample size is 30, for the null hypothesis to be true, then I would take that 30 and divide it into 3 equal numbers, right, to represent the brown, blue, and the green. I take that 30 and I divide it by 3 for the 3 eye colors that I have. So 30 divided by 3 is 10. If I have a sample size of 30 and the breakdown of people by eye color is the same, I would expect for that 30 it would be 10, 10, and 10. Right? That would be my expected frequencies if the null hypothesis were indeed true. So what do I have? I have observed frequencies, the 10, 5, and 15, and I have expected frequencies, the 10, 10, and 10. Then the expected frequencies are built from my null hypothesis, which is there's no difference in the proportion of people with brown, blue, or green eye color. Once I have that, I can thus apply my chi-square test. Right? And the chi-square test is a fairly simple calculation. And as I've said before, in this course, the math is relatively straightforward. Right? Like we're just doing subtraction, addition, division, and squaring. So for each of my eye colors, I take the observed frequency, subtract from it the expected frequency, square it, and then divide by the expected frequency. Right? The top table is the observed. The bottom table is the expected. So for brown-eyed people, for the brown-eyed sample or part of the sample, it would be the observed of 10 minus the expected of 10 squared divided by 10, which is 0. For the blue-eyed people, I take the observed of 5, subtract from it the expected of 10, which is minus 5. I square that value, so minus 5 times by minus 5 is 25. And I divide it by 10, the expected value, the expected frequency. So 25 divided by 10 is 2.5. Similarly, for the green-eyed sample, part of the sample, I have observed of 15, subtract from it the expected of 10, leaves me the difference of 5. I square that value. 5 times 5 is 25. And then I divide it by the expected of 10, which gives me a value of 2.5. So my chi-square calculation for my brown, blue, and green-eyed people is 0 plus 2.5 plus 2.5. I add that up, and my chi-square observed is equal to 5. Okay, degrees of freedom. In this case, if my sample size is fixed at 30 people, and I know I have 10 brown-eyed people and I have 5 blue-eyed people, then there has to be 15 green-eyed people to get me to 30. So if I know the number of people for 2 of the eye colors, the third one has to be constrained to get me to 30, right? So I have 2 degrees of freedom. So the degrees of freedom are the number of category exemplars that make up the chi-square test. In this case, there's 3 category exemplars, brown, blue, or green. 3 minus 1 is 2. So I have 2 degrees of freedom. Okay. I have to find my chi-square critical, right? We're going to use an alpha equal to 0.05. So I want to see whether my chi-square observed of 5.00 is in the top 5% if the null hypothesis were true, right? So if the null hypothesis were true, is the sample that I got, is it in the top 5% of possible samples that you could get? So I have to go to my table. And my table, I go to the column under the red arrow, which is for the top cutoff for the top 5%. I have 2 degrees of freedom. I go across, and the cutoff for the top 5% is 5.991. If my chi-square observed is greater than 5.991, The likely of the probability of it occurring if the null hypothesis were true is 0.05, right? My sample would be in the top 5%. So if I were to run this, if the null hypothesis were true and I run this study 100 times, then out of those 100 times, I would expect on average about 5 times I would reject the null hypothesis, right? So the probability of it occurring is 0.05. It's in the top 5%. My chi-square observed was 5. 5 is not greater than 5.991. Therefore, my chi-squared 5 is not in the top 5%. What happens is I fail to reject the null hypothesis. So, and then I write in my summary, the results of the study failed to show that there was a difference in the proportion of people by eye color. My chi-square observed with 2 degrees of freedom, my n equal to 30, the chi-square observed was equal to 5. NS, not significant. I failed to reject the null hypothesis. Okay, I have a practice assignment here. So for alpha equal to 0.05, complete on your own the chi-square test. We will take this up, but what we'll do is we'll do it in SPSS, and we'll do that later.